welcome to True Projects. In this video, we are going to explain about a project titled An Efficient Approach for Crop Pest Recognition and the Classification based on novel DeepPestNet deep learning model. Ensuring the food safety and enhancing the agricultural productivity have become the paramount, given the impending surge in the global population by 2050. The imperative of pest control looms large in this contest, holding the key to amplified agricultural yield, improved food quality, cost reduction, and the heightened profit. The pervasive prevalence of insect pests on a global scale remains a primary factor behind the agriculture devastation, instigating the disease and consequently leading to the dimensioned harvest. A strategic solution lies in the development of an innovative and precise deep learning model named DeepPestNet, meticulously designed to recognize and categorize the crop pest. This novel approach directly addresses the inadequacy inherent in the conventional pest identification method. The discourse extensively elaborates on the limitation of orthodox machine learning techniques while underscoring the remarkable merits of the deep learning algorithms. Through the implementation of the DeepPestNet, a breakthrough is poised in fortifying the global food security and bolstering the agriculture efficiency to meet the need of an ever-expanding population. In a bid to overcome the shortcomings of the prevailing pest identification method characterized by their intricate algorithm and the restricted data resource, we have pioneered an effective and precise deep learning framework named DeepPestNet, tailored for the identification of the categorization of the crop pest. This innovative approach encompasses an intricate architecture comprising of level trainable layers, encompassing the 8 convolutional and 3 fully connected layers. Notably, DeepPestNet surmounted the challenges that have hindered the accuracy in this domain, achieving the remarkable proficiency in the precise recognition and the classification of the diverse crop nests. Our research extended to evaluating the model's adaptability across the distant dataset featuring the varying type of crop pest, affirming its exceptional versatility and reliability. This pioneering model holds the significant promise in the furnishing the prompt and the reliable assistance to experts and the cultivators, offering a potential avenue to curbing the economic loss and safeguarding the crop yield. And the next one is the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this step, the necessary Python libraries are imported into this environment. These libraries provide the essential tools and the functions for the subsequent stages of the process. And the next step is exploring the dataset. This phase involves a thorough analysis of the dataset containing the images of the crop pest, data exploration, understanding the structure, distribution, and the characteristic of the dataset. And the next one is image processing. Image processing techniques are employed to enhance the quality of the image. This involves the operations like resizing, normalization, and the noise reduction, which improve the overall effectiveness of the model. And the next one is data extraction from the image. In this step, the relevant information is extracted from the images. This includes the features like color histograms, texture patterns, and the shape descriptors that contribute to distinguishing different types of pests. And the next one is of splitting the data into the train and the test set. The data set is divided into the two subsets, the training set and the testing set. The training set is used to train the model, while the testing set is used to assess the model performance on the unseen data. And the next one is building the model. Here various machine learning algorithms are built, and the first one is GoogleNet. It is also known as Inception V1, is a pioneering convolutional neural network architecture. Notably, it introduced the concept of Inception module, and this design enabled the network to capture the features at the various scale and the complexities within a single layer. For our crop pest recognition, GoogleNet Inception module could be highly beneficial in capturing the diverse and the intricate characteristics of the different pest images. And this architecture's capacity to handle the complex and the varied visual pattern align with the challenges posed by the pest identification, potentially enhancing the accuracy of the classification. And the next one is QuizNet. It is a unique deep architecture explicitly designed to minimize the number of parameters without compromising the performance. This makes it lightweight and ideal for the resource-constrained environment, and the pest recognition and classification require the deployment on the edge device on the real-time scenarios. 2. QuizNet could offer a practical advantage of the 5 modules effectively compiled of the 1x1 or the 3x3 convolution to achieve the impressive accuracy with fewer parameters. And the next one is DeepPestNet. It is developed specifically for our project, demonstrate a focused approach to address the challenge of pest recognition. Its 11-layer architecture consisting of convolutional and the fully connected layer indicates a depth and the complexity tailored to the norms of the pest images. DeepPestNet efficacy in recognizing and classifying the crop pest on the diverse dataset showcase its potential to outperform the generic model, given the specific nature of the problem at hand. And the DeepPestNet be adept to capturing the intricate detail and the features crucial for the accurate pest identification. And the next one is exception. As a term of extreme inception takes the inception module, and here this separation allows for the more efficient and the intricate feature learning. For this project, it could excel in extracting the fine-grained pattern and subtle the differences and the pest images. Its deep architecture facilitates a granular understanding of the image content, potentially leading to the improved classification accuracy. And the next one is MobileNet. It is designed with a focus on the mobile and the embedded vision application, emphasizing the efficiency and the low latency. It achieved this by employing the depth-wise separable convolutions that significantly reduce the computational cost. In the context of this project, MobileNet efficiency could be vital, especially to deploy the model on various devices. Despite its streamlined design, MobileNet has shown this impressive accuracy, making it a pragmatic choice for our project. And the next step is user gives the input. A user interacts with the system by providing the input, which in this case could be in the image of a crop pest that requires the identification and the classification. And the next one is the given input is pre-processed for prediction. The user provided input image underscores the pre-processing steps similar to those performed on the dataset. This ensures that input is in the suitable format for the model prediction process. And the next step is trained model is used for prediction for that image. And the selected model which has been trained on the training data is used to make the prediction about the given input image. The model learned feature and the pattern help to identify and classify the crop pest in the image. And the next one is final outcome is displayed. The result of prediction is displayed to the user. This includes the information about the identified pest type, potential impact on the crop. And the next one is execution of the project. For this, we need to open the code folder. And this is the code folder containing of various files within it. The sample folder containing of the various folders which containing of various images within it. And the static folder containing of folders like CSS, JavaScript, fonts, images, uploads within it. And the template folder containing of the HTML documents typically include of gram, home, index, notebook, sign-in and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And a notebook is an IPYNB file which contains the combination of the code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a database file that uses it to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and then click on the enter button. Here it will redirect it to this page containing of some information about it and the title of the project. Then click on the sign up button. Here it will redirect it to the sign up page containing of some details that are need to be filled to create an account. But my account is already created, that's why I am using the sign in button. Here it will redirect to the sign in page containing of username and password and that we need to be entered, and then click on the login button. Here it redirects to this index file containing of choose file and upload buttons. Click on the choose file button. Here it will redirect it to this folder containing of images within it. I'm selecting one and then click on open button. And then click on upload button. Here it will redirect it to the result page and giving the prediction of the uploaded image as of the type armyworm. And by using the try again button, we redirect it to this page and we can choose the another files too. I'm clicking on the choose file button, I'm selecting another one and then click on the open button and then click on the upload button. Here it predicted the image as of armyworm. And this way we can predict the pest by using the images within it. And in conclusion, we confirm the effectiveness and the robustness of the proposed DeepPestNet framework for the pest recognition and the classification. The proposed model achieved the best accuracy in recognizing and classifying the different type of crop pests and the best accuracy on a different data set with the different type of the crop pests. We suggest that the proposed model can help the specialists and farmers identify the pests more quickly and effectively, thus reducing the economic and the crop out losses. We highlight the need of expand the classification size by including the more pest types to effectively identify by the proposed DeepPestNet framework.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.